did this between subjects. Design had those pairs for 4 separate images. So one person would only go through one questionnaire for 4 images. So what we were trying to do here is get people into a sort of tug of war between their trust in the representation of the subject and their trust in the subject itself. So that's how we looked at how we selected the images. And what we sort of were trying to get at as well is that this sort of in two minds tug of war was happening in the hot system processing. So the very basic sort of intuition type system of cognitive processing rather than a cold analytical system. So to do that, we put a time limit on the exposure, exposed it for 1 second, the image so that we can try and prompt them to make a quick snap decision. And that's just an example of how this was displayed to participants. We then asked the question sort of simultaneously, so displayed it at the same time. We also gave it to them before they viewed any of the images. They had both the questions in mind at the same time, and the answers were combined answers, so yes, 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 no, etc. We also asked them for a confidence rating and then a reflective reasoning as well. And these are the images that we used. So we altered them so that they could be noticeably altered because we wanted to sort of get them in that sort of frame of mind. We've got sort of dangerous or untrustworthy type subjects at the top and more trustworthy down the bottom, and that's the way they were altered. So that's the original images there, and they were altered to look like that. Okay, and then I'll pass over to Peter for how we analyse the data.
First of all, I'd like to thank Ariane and all the organisers for organising this conference. I'm very happy to be here. Noah and I came a long way from Australia, but this is a wonderful community. I've been engaged with it from the beginning, and I continue to find this a very, very worthwhile forum. So I'll go to the presentation now. So just to recap, the question that we're trying to answer is, are decisions of image trustworthiness, are they contextual? Right? So this decision is a cognitively situated decision. And how would we go about doing that? So we have this Bell scenario design where, for those, many of you know what that is, but I'll recap what that is. In a Bell scenario design, you have two systems, A and B, right? And each of those systems, in the simplest case, you can ask 2 yes/no questions, right? And then that gives you 4. So you've got 2 questions for system A, 2 questions for system B. So that gives you 4 experimental contexts where you ask a question of system A and a question of system B. So we're trying to replicate that particular design in order to determine whether the underlying decision making may be contextual. And so in order to do that, you need to be able to collect some data and subject it to a particular type of analysis. Now, I'm going to go through some steps now about how we analyse the data, and the reason I'm doing this is this particular analysis method has been developed by someone in this community called Edibar Zafrov and his colleagues. Now, the reason why this particular analysis is very significant to this community is that when we're trying to use the Bell scenario design or the EPR experimental protocol, one of the requirements in quantum physics is that there can't be any signaling between systems A and B. Now, this is a very, very challenging thing to do in cognitive science. So what Zafrov and his colleagues did is that they managed to generalize the CH-SH inequalities, which are used in quantum physics verify the presence of contextuality, and they managed to generalise in the sense in the following way. So there can be a certain threshold of signalling, and when that threshold gets too high, Zafarov and his colleagues say we can't talk about contextuality. So below that threshold, we are able to talk about contextuality, and I think this type of analysis is very, very relevant to this community, because it's very, very hard for us to deal with this problem of signalling between two systems. So I'm going to go through that now. So this is obviously too small for you to see, but so what we do is that we've got a spreadsheet at the top. We calculate, we collect the data in the 4 experimental conditions. At the bottom, this is the grid of four pairwise joint distributions that come out of the collection of the data. And you notice the C1 and C2. C1 is a question that's given to the content decision subsystem. So this might be the question: do you think that Putin is honest? Right. R1 might be a question: do you think the image is being manipulated? So we always ask one content-based question and one representation-based question. So it's simply a question of coming up with the design of the experiment and collecting the data. So the second step in Zafarov's method, we have to compute certain expectations. So up the top we see the grid of probabilities, and then you see these expectations around all those sort of variables. So I'll give you an example of the first one. C1.1 means the content question that has been asked in the context of R1, the representation question. So Zafarov uses this double indexing notation because he's saying that the content question C1 is not a globally defined variable. This variable has a particular identity that's unique with relation to when it's asked with question R1 and when it's asked with question R2. So he does this double indexing to separate the functional identity of the variables. Okay. So this is simply a computation you can easily do on that grid. Now this is the one that I think is very relevant to those who are doing these sorts of experiments in cognitive science. So what you do is you compute those expectation values, and at the bottom there you see this calculation delta 0, and this is a calculation that's essentially working out the level of signalling between the two systems, right? So when you've calculated delta naught, there are two things that you need to worry about. If delta naught equals 0, what this means is that there is no signalling at all between the systems, so then you've got exactly the case that you have in quantum physics. So there is no signalling going between system A and system B. If delta naught is greater than or equal to 1, so that the degree of cross-influence, or the degree of signalling, is deemed to be too high. So if delta naught is greater than or equal to 1, that means that there's too much signalling going on between A and B in order for us to meaningfully talk about any contextuality. So this is Zafarov's opinion, right? So there are others in this community that might not hold this opinion, but we're following his particular analysis method. And I should mention in passing that this particular derivation of this degree of signalling has also been similarly calculated in quantum physics. So there is a researcher called Chavez at the University of Queensland working in the quantum information science area. He and his colleagues have been working on some analysis of Bell-type experiments where there is signalling between the two sides. And he came up with the same threshold, the thresholds that Zafarov came up using completely different formulas and completely different derivation method. So it seems like that both of them have come to the same underlying theoretical boundary, and the fact that they both came up from different directions is perhaps suggestive that there might be something significant.
Okay, so what happened in our case, we've got the 4 images. We've got putin, shark, girl, and antelope. You see that that value of delta naught is all less than 1. So that means, according to Zafirov's approach, we can apply the generalized Bell inequality. So we're within the boundaries. Okay, so the next step 4 is to compute the correlation. So like C11R1, that's the top left-hand side, so we calculate P1 plus P4 minus P2 plus P3. This is a standard way of computing correlations between 2 variables. And then here we have the CHS inequalities, but these are the generalized form that Zafarov and his colleagues have put forward. And then you notice that on the left-hand side is exactly the same as it is in the physics literature. The right-hand side is what's of significance here, because usually the boundary is at 2. But you see that the boundary is being modified by this delta naught. So that means that when you've got some signaling, the boundary between a classical system and the quantum system is not 2. It's subject to this degree of cross-influence. So that's why it's viewed as a generalized system of inequalities. Because when delta naught equals 0, you've simply got the standard CHSH inequalities. So what happened? So in the end, it all came to nothing. So this is an example of the putin. So if we asked the question, we had a group of between subjects design of about 30 in each experimental context. We collect the data, we run the analysis, and you can see here the correlation C1, C2, C3, and C4. They're all less than the 2.8. This is the adjusted boundary according to the signaling. So all the inequalities pass. So according to this particular analysis method, we can't conclude that in the case of putin, that there is any sort of that the decision was contextual, and all of our other images suffered the same fate. So even though we started with this assumption that there is something going on between, like that participant said, they couldn't separate the decision about putin from what they know of him as a person, and with respect to the image itself, they couldn't separate the decision-making process. So that suggested maybe there's something contextual going on. We didn't find it. So what we're going to do is, why is that? So we've come up with what we thought is a clever design. We felt that we designed it in a way that's sort of valid and justified with respect to the sorts of experiments they do in quantum physics. We applied what is, I think, a rigorous analysis method, and yet we don't find any evidence of contextuality. And this has been happening again and again in this community. So the EPR design or the Bell design has been applied a number of different times, and usually nothing comes out of it. And so at the end of this experiment, Laura and I asked ourselves, what's going on? Why can't we show this? And so the only definitive one that we know of so far is Zafarov has done a human choice experiment, and he's used the Bell scenario design and managed to get some violations. But a lot of us have tried this and it's failed. And here are our reflections on this. Like, so the problem. So the problem that we have in cognitive science is the following. So in order to get a violation of the CHSH inequalities, you need very, very strong correlations. Right? So you need to actually design the experiment so you get strong. Ideally, you get 3 positive correlations and 1 negative correlation. Right? So that would be the ideal. Now, what we found is that when you design an experiment that way, you get very, very high correlations. A consequence of that is that you tend to get a lot of signaling going in between the 2 subsystems, A and B. Right, so there seems to be, at least in the experiments we've done so far, a trade-off between getting very, very high correlations and also trying to keep the levels of signaling low enough to be sort of kosher with respect to the Bell scenario designs that they do in physics. So this is an example here of another study we did with conceptual combinations. We're looking at a combination like apple chip to see whether that's its interpretation is contextual. You can't see it on this diagram, but here the correlations are very, very high. So that's good, because that gives you more chance of producing a violation. But also that red area also suggests that the signalling is very, very high. So we noticed this we tested about 24 conceptual combinations. The ones that had very, very high correlations also had a high level of signalling. The ones that didn't have high correlations, they had less signalling. And a similar sort of thing here is this design we did with the images. We designed it in such a way to try and reduce the level of signalling. And I think my gut feeling is by doing it this way, we also eliminated to a degree the possibility of getting correlations that are high enough to violate. So the take-home message, at least from our side, and this is, I think we need to go, in this community, we need to go beyond the Bell scenario experiments. Because I think cognitively, these are very, very challenging experiments to do, right, and to get violations. And it's obvious why this community took that Bell scenario EPR design, is because these are the most famous in physics, and there's a quite simple protocol. But it's not working too well. And I fear if we continue to do this here, what's going to happen is that we will continue to have failed experiments. And I think that we're missing the possibility of developing other protocols which will allow us to show contextuality much more easily in the context of cognitive science. So I think one of the things for this community is in terms of research, is to come up with these protocols, right? Because we've been struggling for a number of years now with this Fell scenario protocol, and I feel it's not working, and I think it's very, very hard to get it to work. Okay, so I think maybe that's sorry to get up on the pulpit and preach to you about this, but that's really, I think, the main thing that we wanted to share with you, is that it's the difficulty of using this Bell scenario design in cognitive science, and I think we need to look beyond that. So we started to do that, and I think I'll hand it back to Lauren, and she's going to talk about a design we're proposing that isn't a Bell scenario design that involves another test to determine the presence of contextuality. And our hope is that these sorts of designs are going to be simpler and much easier to run with human subjects. So Lauren, I'll leave it back to you.
The other reason that we thought we weren't finding contextuality was that we weren't truly accessing the hot system, because all we did was show the image for a short amount of time. So we think that perhaps that was still accessing the cold system and coming into play our past experiences and memories associations, which are different across every person completing the experiment. So contextuality may be getting lost in all of those extra variables. So we focused on, we're trying to focus on accessing the hot system better. So we've done 3 things. So we're downplaying the importance of the question to participants. We are placing their time limit on the answering of the questions rather than the view of how long the image is displayed for. We're also changing the wording of the questions. So, do you feel a sense of trust? Do you feel this image may be photoshopped? Just sort of getting that more emotive language rather than something that might prompt analytical thought. These are the images that we've used for this one. Instead of bringing about preconceived ideas, such as using images of Putin and things that people recognise, we've got effectively strangers, and we've done a bit more work on manipulating them a little more obviously, but still not, too much that people can pick out particular points in it when they're viewing it quickly. And this is the sort of data that we're hoping to see. It's a little bit fuzzy and small, but for this particular image, for example, we're expecting a high proportion of people to say that when asked, is it photoshopped and do they feel a sense of trust, we're expecting them to be in the yes, it's photoshopped no, I don't trust it care. When trust is asked with attractiveness, we're expecting there's more to do with yes, yes care. So yes, I trust it, yes, it's attractive, because we know that those two can be linked. And then when we ask attractiveness in Photoshopped, we're expecting them to be in yes, yes again. So we're looking for two positively correlated sets and one negatively correlated one. And then we calculate it in this way, and then using this dummy data that we put in just for today, because we haven't had a chance to actually run it. If this came out in this way, then the inequalities would be violated. So yeah, that's what we're hoping for the next one. Yeah, just to summarise, I think we're through this, but we wanted to look at, we still want to look at trustworthiness and to see if it's contextual in the sense of whether content and representation are also linked in some way, and we did find contextuality, but we're proposing some experiment that will hopefully work a little better.